Hi friends, this is Arun. In this video, we'll have a look at binary trees. So it's more of a theoretical session this time, but this is very important, and this is a little important to understand a lot of other things. Okay, so the binary trees are nothing but trees with two leaves. Okay, so let's first look into what is a tree. Then let's go into binary tree and what are the various terminologies to do with that. So when you start with the trees is nothing but like the trees which we see around the physical world. It is something as a root and then has a lot of branches and has a lot of leaves. Okay, assume if the trees are forced to have only two leaves in every branch. Okay, so that's called its binary tree. So the edges are called the branches are called edges, whereas the nodes are called leaves. Sorry, leaves are called nodes here. That's it, simple. Okay, and one important part is like there is no circular path in a tree. When I say circular, so not the leaf node is connected to each other. Okay, so if it is connected, then it is called a graph. Okay, so trees is like a is a special form of graphs only. Okay, so this is about trees. Then let's move on to the next topic. So if you want to emulate a hierarchical structure in a computer program, the best way is to do the best data structure to use is a tree. Okay, it's nothing but a linked list, but having two nodes. That's it. Okay, two nodes at every level. So in linked list you will have only the next, right? Here you will have a left node and a right node. Instead of single pointer you will have a double pointer, and that name is called right and left. That's all. And in the trees we have different type of trees: binary trees, b trees, and multivariate trees. So our main focus towards binary trees, and b trees are mostly used in database indexing and other stuff, so which we'll see it later, or we'll skip it for this thing. And multivariate tree is a special form of trees as well. There are various jargons with the trees. For example, by a tree, binary search tree, binary tree, AVL tree, in-memory trees, red black tree, 2 3 trees, n-way tree, on disk data structure, b tree. So like that, self-balancing binary tree. Okay, so again naval trees come in. Okay, I have put it twice. So by b plus trees, b minus trees. There are a lot of jargons or a lot of different variants of trees itself is available. So first let's try to understand how one word is associated with the other, so that we'll have a broader look. It's like a eagle's eye thing. So let's start with the tree. There are mostly two major categories. One is binary tree and a B tree. Okay, as the name suggests, binary means it's two, 0 or 1, like that. So here binary is left or right. So one is binary tree, and B tree is like it's the number of leaves it can have is more than two. As simple as that. Okay, it's couple, it's more than that. So that's a primary difference between these two guys. These are the primary variants of things. And then in-memory trees. So typically binary trees are in-memory tree. When I say in-memory, every data is stored in the RAM, and it can be accommodated within a RAM. Whereas B tree is morely disk-oriented data structures. So where we store it in the file, whenever we want, we pass by chunk, and then we move on. So that's why most of the database management system uses B tree internally for their indexing. Okay, that's they are called on disk data structures. These guys are called in memory. Okay, so then binary search tree is a specialized form of binary tree in which it has a rule saying that my left should be lesser than my right, myself, and right should be larger than me. So if I have two nodes and I am 10, so my right should be 12 and left should be 7, like that it is. If it is not there, so then we have to balance it, so rearranging the things. That rearranging is called self balancing, and there are different mechanisms to self balances. One is AVL tree, all the rotations and other things are there. And 2 3 trees are a special tree, are a special case of binary tree. Okay, and as I said, AVL tree comes in the self balancing thing, and even red black tree comes into the same part. Okay, it is also a special way of organized binary search tree. Okay, these are some of the terminologies. And B trees, B plus trees are different variants of B trees only. Okay, so they are multivariate trees basically. Okay, so these are some of the jargons which is associated with the trees. So let's start with the binary tree. Binary tree is a tree with a single parent and multiple children. Okay, when I say multiple children, it's 0 to 2 binary, so it's not more than 2. It can have 0 children or it can have more than 2 children. Okay, so like this it is. So this is a binary tree. Every node has 2 children. Okay, 0 to 2 children. And this is, sorry, first is a normal tree, second is a binary tree. I missed to see that there are 3 nodes in that. So in a binary tree, see, it looks like a happy family, like v2 we have one instead of here, like v2 have two kind of model. And let's go to further jargons in binary tree. So the topmost guy is called root. Okay, your great great grandfather. Okay, and the bottommost is called the leaves. Okay, you are the grandchildren, let's put it that way. Okay, and this is called left subtree, and that is the other one is right subtree. All are by the name, you can understand. And this is called a level, like level 1, level 2, level 3, level 4, like that it is. So it's called a level. So the next set of terminologies are root and leaf, as we saw it. Like, so the leaf has no predecessor, and sorry, root has no predecessor, leaf has no successor. Whereas interior are called as non-leaf. Height is the leaf from the root to leaf. So what is your height of your family? Kind of it, like from your grandfather to your grandchildren. What is the number of levels you have? And skewing is like if the binary tree is not ordered properly, it is not balanced properly, it will end up in skewing is a normal English word, like skewing towards left or right. Okay, leaning towards left or right. So as I said, there was a binary search tree, right? So in that we have a condition, left should be greater than right, should be less than right. So if assuming if all are coming in a sorted order, so it will look like a skewed tree in one way, either in the left side or right side. Okay, so this is a visual representation of what we had in the saw in the above. Root, interior and leaf, and height is the overall. This is a skewed tree which I have shown in the last, all the black dots. Okay, so the next set is like a size and depth. Size is very simple, total number of nodes is the size, and depth is like a, what is the depth from a root. For example, every level you have a depth. For example, for A the depth is 0, for E the depth is 2. So it's just a counter. Okay, so the depth of the binary tree is the deepest. I mean, if it is from leaf to root, it will be the same as the height of a binary tree. Okay, so that's these are some of the jargons. So in this, it's the height and depth is 4 here in this tree. So the next is full binary tree. Full binary tree is very simple. If the tree is complete or properly having 2 child nodes, then it's called a full binary trees. And obviously if that is proper, the length of any node would be identical, the path. Okay, so the height of the path would be the same at any leaf node level, because it's properly constructed. We have seen binary trees. What is the use of binary trees? That's the next question. So obviously, as we visually see that it can represent any hierarchy. Apart from that, let's assume if I want to parse this mathematical expression, and I'm writing a compiler or a calculator, whatever it is. Okay, so I can represent the entire equation in a tree format. It's called expression trees, and then try to solve it no level by level. Okay, very simple and straightforward. This is the way where we represent the infix notation as a converted into postfix, and postfix is represented in the tree format. Sorry, tree, not three. Okay, so we solve at every level, and then level by level we ramp up and then go to the root node. Okay, so this is a simple usage of a expression tree, or trees basically. Okay, the tree is represented in same as the linked list. See, we have a data node and 2 pointers. So I mean 3 pointers. One is for parent, another for left and right. The parent pointer is not mandatory, but left and right is always mandatory. It depends on the tree structure if you want to have a parent or not. Okay, so even the binary trees can be represented in array format, not only in the pointer format. But the unfortunate part of the array format is the reshuffling. If there is an insertion in the middle, there is a lot of trouble in that. Okay, so that's the reason why people don't go for array format. And couple of questions to end up the session. So in a full binary tree, what will be the height, how many leaves will have it, and how many nodes will have it, all those things. Okay, thank you friends, bye bye.